ready to go.
Okay. Good afternoon, good evening, good morning. My name is Bob Martin. I'm from MITRE Corporation. If you haven't heard of us, look us up. We a private company that runs what are called federally funded research and development centers for US government. Do a lot of work in the industry, and I'm hopefully going to tell you a couple things you don't know, support some things you already believe and do, and maybe spur on some good discussion. So my focus is going to be around software supply chain and some efforts in that area. Kind of as background for that, I like to, I get the opportunity to talk to a lot of people who haven't, built software in a long time or never. And so I use the analog of software as just another building material. And you need to be careful which, pieces and components you select, but you also have to think about how you're going to assemble them and what the actual task that software is going to be achieved and the stresses and constraints that it's going to face. Because even such little things as the grout and the chemical composition and the amount of water you put in it can totally change the, as we say, operational behavior of the resultant structure. Similarly, the way you select your configuration of your build environment and the settings and the way you compose your software can drastically change its behavior from one that's very predictable and safe and resilient to one that's chaotic and totally attackable or exploitable or just haphazardly fails. One of the other things that I like to present is the fact that the world has shifted a lot in the last couple of years. A lot of people think, computers they think just traditional, environments, kind of your IT world. But as you all are aware, software and microelectronic and networking has invaded every kind of system that supports today's way of life. At the same time that was happening, we went from projects that pretty much started and built their entire application to one where we mostly assemble software, or a good portion of our software is assembled, and therefore it has a supply chain. So you put those two together, and we've gone from a world of, quote, IT risks to one of operational risk. And when you start talking about that, whichever context you're in, you need to think about risks in a very careful way. So when people often talk about risks, they don't think about the other side, which is the quality gaps, whether that's in secure behavior, safe, privacy issues, resilience, or reliability. And it's not that you just need to be perfect in all of these areas, but rather you have to figure out what is your minimum requirement and where is the project and what is the gap. So one thing that I've been involved in is the Industry IoT Consortium, where we treat these behaviors together as trustworthiness in spite of attacks, environmental disturbances, faults, and errors. And they're kind of amorphous, that they can be more or less safety for a particular context type of system. So something for you to possibly look at. The other side of this is supply chain. So often people think of a supply chain as, well, I'm the customer, I have a supplier, maybe I'm a company, I have a manufacturer, or maybe I'm part of a supply chain, so somebody who integrates things for me. But in reality, there's more out there, but we don't have a good picture on it because of confidentiality, trade secrets, just normal practices. And yet more and more of these things are very important to more of us. And so getting some clarity into that supply chain and visibility, not necessarily because we want to know the trade secrets, but because we want to know what's in the things we rely upon. And so one of the things that has happened in the last 5 years is a lot of discussion about software bills of materials and standardizing those. And so when you look at a software bill of materials, you'll find some audiences talking about them as, well, it's everything to do with how it was built, the pieces, how they come together. Others will be talking about the software bill of material for that thing I can download and make use of. And others will talk about the software bill of material of what's running and in use in operation. And so these are basically different life cycle phases of the same stuff. And so being able to relate these and show that, they're not three things, they're just three parts of the life cycle of one thing. So in that world of software bills of materials, there has been the software package data exchange, SPDX, OWASP Cyclone DX, and SWID tags from NIST and ISO. Of late, the ISO SWID tags have kind of shown that they're not really up to the stresses that today's discussions about software bills of materials are putting on it. So it's really not a contender. It's a good way of identifying components, but not carrying the kinds of information that a lot of people want to do with their SBOMs. So real quickly, I started an effort back in 2019 aimed at trying to bring the tooling community together on a standardized SBOM. That was out of the object management group and the Consortium for Information and Software Quality. And we drove this effort through some specific scenarios. There's a link at the bottom here for this paper, but basically, we wanted to be able to refer to something, understand its pedigree, its provenance, have confidence that it hasn't been corrupted, that it is what it's supposed to be, that it's, understand the rights and obligations from a legal and licensing point of view, know about vulnerabilities, but also how can I gain assurance and confidence that it's safe, secure, resilient, and trustworthy, basically. And also how to deal with the fact that software is often presented to us as a service where we, ping some API and something gets done for us. And how do I understand the bill of material of that? What was running when that was invoked? And then was that a liability? And is that where I'm going to be, brought to my knees because of some problem in a service I don't even have the code for? And then the whole idea of the supply chain and the integrity of the supply chain. So we basically merged our effort with the SPDX effort, and that now comes onto the landscape of discussion, which a lot of it focused on end users, talking to those who produce a product or service to them, whereas what we were talking about was the underlying tools that enable those producers to create software. So SPDX 3.0 and the what was called the 3TS bomb have merged or integrated. And that's one of the things I want to talk about, which basically the 3.0 version of SPDX is talking about a core bomb, and then you're bringing in profiles, whether that be for licensing or software or other things, radical things like a hardware bill of material. And that opens the door to other communities, those who, track and trace and work with physical goods. And in fact, other things are changing. The work that was at NTIA is now transforming over to work centered out of SLSA, once they can figure out all their legal and obligations and constraints, get through all the lawyers. There's but also, though, in a different part of DHS, SLSA, a hardware bill of materials working group. And so I'm trying to get them to help define what that hardware bill of material profile could be. So enough words. What is SPDX 3.0? May not be more than an eye chart to you, but if you look at the top 2/3 to the right, you can see there's this thing called package core. And then below is a package software. So this is that idea of a core bill of material, and then you can add in concepts to handle software. And so in the top, there's the things we think you need to manage a bill of material. The thing that you convey, who's involved in creating it or authoring it, external references to things about the bill of material, ways of checking the integrity, and so on. So these building blocks, we're getting very close. I think Kate and I have our fingers crossed right now, but very close to having that done. And I want to relate that to some other efforts that are going out in the community that really link together and leverage each other. So a little over a year ago, the world discovered that the company SolarWinds had a visitors that had come into their networks and basically gotten to know how they build code, how they move product out to customers. Based on that knowledge, they actually altered their build environment so that it would, basically insert a Trojan into the package as it was being created. And then that went out to SolarWinds customers, where that capability was then visited by those bad actors. Not all of the customers, but a lot of them. A lot of disruption, a lot of concern, a lot of energy has come out of that. MITRE put a paper together, which is linked here, talking about, well, how can we address that? And basically what we talked about was, one, you really need to secure and harden your build environment, have role-based access and management, so that some developer isn't changing the build machine, and some tester isn't allowed to commit code, and things like that. And some random person isn't allowed to come in and do all of those. The other thing, though, we talked about is introducing bills of material, but not just in the output, but rather as part of the process of building code. And not only that, but signing it and tying it to the different activities that are being done and to the chain of events that are going on as you create that software, so that at the end you have this chain of evidence to support why someone should trust that the right things were done in the right places. And when you get to a release, you can make use of that information, compare it to what you were planning to do. And there's a nice project in the Linux Foundation called In Toto that describes that architecturally, has a lot of the mechanisms. And we talked about that in the paper. And we also then talked about how, that could then transition over to the consumer, where if they had visibility into that could be why they trust a new release, or if there's some translation of that into the end customer, they at least will have a bill of material that they can use to know what's being deployed. They can track disclosures about that and use it to monitor and manage their environment going forward. So if you step back and look at other efforts in the community, the software, SLSA, I can't remember what it stands for, but basically they were looking at the same issue and had started identifying the different places that software creation process can be compromised. But if you look back a couple of years, MITRE actually captured a lot of these in our common attack pattern enumeration catalog, KPEC. So, these aren't brand new things that we're talking about, but we're now talking about putting more energy into them, because the bottom line is, attackers want to have operational impact, and they want to find a way to get through and impact critical items that have either functionality or a critical asset that reflects in that operational capability. So whether you're following a V type of development, or iterating and visiting the different steps incrementally, there's a lot of good material out there on how to do software creation, evaluation, and evolution. And there's a lot of information in that process that can be used to gain confidence that the right kinds of things were done, the right kinds of evidence is being collected. Some of them are manual, some can be automated. When you start to get running code, you have much more things you can automate. And then you can also play around with both automated and, smart people finding their way into systems. All of these, though, along with others, are described in the document that's at the bottom of this. Another thing we produced in the Industrial Internet of Things Consortium. And ISO has started actually getting product level, code level standards. 5055 has a list of things you don't want in a system. So kind of to summarize this little point is, there's a lot of artifacts. There's a lot of methods of looking at those artifacts. They have different coverage of what they can find and indicate. And so what you want to do is understand how, things can fail, whether it's from a safety issue or a security issue, reliability, and you want to be able to make attestations about that. But you need to make sure that the evidence you're bringing is brought to you by a capability that actually can find the right things. So of all the things you care about, put together a mosaic of the abilities to find and show that they aren't there, or if it's a positive claim, that they are there. And so when we go back to the supply chain levels for software artifacts, SLSA, and look at that, they're basically offering up these different levels to give you a way of summing up the things you're looking for, whether that be hardening the environment or being reproducible builds or other kinds of activities. The interesting thing is that they have a way of conveying that in language. And so the idea here is that you could make different kinds of attestations, have them signed by authority and brought to the next step in the supply chain in a more structured way. So I want to quickly talk about the supply chain end of all this. When we think about a product, okay, a product probably has components. Those components are, being created, and there's some organizational structure. I'm giving you a very kind of formal contractor type relationship, but these could just be teams and sub teams. But this is not necessarily how reality is for products and teams. So if you think about just a simple thing like consumer clothing, they have raw materials. Some of them are harvested and processed. Some of them are, creations out of chemicals and others. These basically, come together, and you have the garments. You bring in, kind of accoutrements to it, and eventually it gets into some kind of distribution, and then it comes together and comes to the consumer and gets end of life. Well, those come from many, many, many places. So when you look at this model, you have to think about it as well. Actually, there's some kind of a distribution process going on. And actually that distribution actually has transporters, whether this be in the physical world where goods are being moved around, or in the cyber realm where you're moving code from one repository to another. And there's also information flow going from the consumer, from the producer, and often there's money flow. So there's a lot of things that you need to gain confidence and have assurance about when it comes to supply chains. So I wanted to tell you about another effort out of the Linux Foundation, but this one's also tied to the IETF. So in the IETF, it's called the Supply Chain Integrity, Transparency, and Trust effort. I didn't update the slide. We were debating whether it was trustworthiness or trust, and we went with trust. It's a confidential ledger-based way of capturing attestations as they happen wherever they're happening in your supply chain. Basically, I'm going to walk you through this in the next slide, but here's the words that go with it, and you can sign up and join that effort. The Linux Foundation will be the community effort of this, and where the open source capabilities enabling this are happening. The IETF is where two standards, at least, that we've already positioned will be coming from. But the way to think of this is there's a ledger store out there that has the integrity and security capabilities, and your organization can establish policies about what attestations you need for what kind of situation. Earlier today, we were talking about safety systems. And so you could think about these as, what are your minimal safety requirements? What kind of activities, actions, evidence need to be collected in order to be comfortable that it's being met? And so a supplier needs to go through taking their artifact and getting it through attestations, whether that be from self-attestation or third party. And then this set of attestations, claim plus evidence, would be added to the ledger, and it could be done by several participants in a particular software supply chain. And then when someone in a end user environment wants that product, it's the attestations are pulled from the ledger and compared to policy. And so think about that from a safety environment, what it could enable. the two draft standards, they were presented 2 weeks ago at IETF 113. Basically, one is the overall architecture, and the second is for countersigning evidence. What that means in context is that there's a ledger capability, which would be covered by the standard, but we're also going to make a reference implementation open source. And you basically, through distributed ledger, hardware root of trust based service, you can bring in a claim, you can countersign it, and it's available for anyone to look at, even if the service is offline. So kind of going back to that build environment that we talked about earlier, and the different activities, here we're now talking about a policy store and an evidence store. And so the idea being that evidence can be brought in and compared to policy requirements. What I want to take one step even further away, though, and talk about this in the context of overall enterprise supply chain management, because software eventually, whether it's in a device or just software, comes to enterprises. And MITRE's been doing some work in the last couple of years on how to bring some structure and repeatability to the way enterprises think of supply chain risks. So think of the system of trust as a strategic, widely useful way of looking at supply chains, but let them focus in on a subset of those for a particular case. So we've basically been harvesting and getting with experts about all the different supply chain risks that can come from your supplier, a service provider, or the item of supply, and organizing those, correlating them, deconflicting them. And if we're totally successful, we'll fail if we don't also give a way of trimming that down to some subset appropriate for a particular project or a particular transaction acquisition. And so a lot of our energy has been on how do we then get to that subset so someone has the right set of risks for their situation. So basically what we've seen is people, when they think about what supply chain risks to manage, have two approaches. One, they start with a blank sheet of paper and start thinking about all the things that can go bad and that they need to worry about. And of course, they're using their own terms and terminology, and no one else will ever understand what they're talking about until they translate it. The other way is people look at somebody who seems to be doing well in supply chain and says, can I crib from you? Unfortunately, they may have totally different priorities, totally different kind of systems, different aversion to risk. And so they end up tearing up what they're doing and rebuilding it also. So I think we can all agree that one part of supply chain risks is coming from third-party risk management. But do we all understand the kinds of risks that dealing with a third party could come to bear on your project? Do we understand that we need to think about attackers and counterfeits, that we need to think about all the natural disasters and hazards that can interrupt our plans and approaches for our supply chain, and human hazards and disruptions, whether it be corporate corruption, national corruption, civil disruption, all kinds of things that you may need to consider. Not always, but you may. So system of trust basically looks at three different aspects of trust. So for the suppliers, supplies, and services, we've come up with 14 top-level risk areas that we think cover the waterfront of things you may need to think about. If you're familiar with the world of accounting, You may have heard about generally accepted accounting practices. Your people who support your project and do finances, they don't come up with some new approach from a blank sheet of paper. They look at the generally accepted accounting practices and then find that subset that's appropriate to what your project wants to do, how you're going to run your team, how much resources you have, and so on. Well, we want to do the same thing. So what is that superset, though? So in external influences, here's some examples. These go in more depth, but in financial stability, there's things, how do they manage their debt? Are they a good financial steward? How are they dealing with, are they profitable? Are they, susceptible to someone trying to play them through the foreign influence? Lots of different questions there. In hygiene, you could think about it from a hardware or software point of view. And here's some of the topics, and I think some of these will resonate with many of your efforts. So what that all comes down to is this kind of landscape about risks that can come through the supply chain, and getting a vocabulary of those so we can actually have a discussion about which ones we care about and which ones we focus on, and what techniques can be used to give an assessment and evidence about where we are on these is really the core of this. So we have this pretty overwhelming taxonomy. We're still working to perfect it, but we have a knowledge model underneath it, because the way we can winnow this down is we've built an application. It's a cloud native application that we'll be open sourcing. And basically it's what we've built, that taxonomy, how we manage it, and how we will allow people to go in and select a subset. The idea is you could do assessment on that system, but most people who are doing this kind of assessment are very worried about the details. So we have the ability to create a spreadsheet once you've down selected to the risk areas you're going to address. We've done many, many rounds of piloting of this, and we continue to pilot. We've also been looking at how to present the results, because if you get a lot of data, a really bad piece of data can get overwhelmed by lots of good data, and you can miss that showstopper, which may be the thing that tells you why you shouldn't go with this supplier or that item of supply. So to kind of bring it all together here, we got this data model. We're basically, building the system of trust taxonomy off of that. If you have a particular focus for a project, you're going to end up with a subset of that. And, then you do evaluations against that. If you have a different scope, you end up with a different subset and a different basis for assessment. So this is real quickly pilot one, an effort we did with 11 companies. You can see the blue area. Think of that as the risk surface. You can see they have different amounts of risk surface, but maybe you can't see really well. So let's zoom in here. Basically here you can see the midnight axis was plotted to 0. So if you look at the sub criteria up in the upper right, you can see that there was nothing that went past green in a stoplight interpretation. Whereas some of these others, there were things that could be disturbing depending on what you want the supplier to do for you. And so these risks aren't don't deal with them, do deal with them. It's just trying to identify the risks so you can manage them. This is an example of a supply item, software supply item assessment using different risks for that area. You can see the details around the slide. But the idea is not that this means you don't deal with them, but rather you know what risks you have, what mitigations you may want to plan. So the tool itself is access controlled. This is the full-blown version that we use here. So we not only can look at the content, tailor down to a subset, but we can also build and edit and evolve the content. Most people won't have access to that part, but then we also can do assessments online. We're going to make a version available at MITRE.org in the fall, and there you'll download a spreadsheet where you can do assessments on your own systems and properties. So the idea here is that many people are looking to purchase or bring in services. There's a lot of different kinds of roles and activities, and there's a lot of confusion and talking past each other, a lot of wasted energy. And so we hope that System of Trust will give them a common place, common context, make sure people don't forget important things just because they haven't run into it before. Somebody in the community has. And so we think System of Trust will move the ball forward a little bit in this area so the discussion can be more structured and more learnable and easier to apply for everyone. Much like the MITRE attack framework has been in enterprises dealing with attackers and what techniques are being used against them and what they can do to discover it and protect against it. So we have a whole bunch of different areas that we're pursuing with our sponsor, our customers and government, with industry, and with everyone in general. One part of that is outreach. A lot of discussions over the last 2 years. Some audiences that I didn't usually talk with, like people in government, including people in Congress. And so a lot of things, trying to get as much of that out in the public. There will be a sot.mitre.org by June. I'm giving a talk about this at the RSA Security Conference. So with that, I think we have a couple minutes for discussion. If there's any questions or comments or things people would like to share.
Thank you very much, Bob. Just to get things started, and anyone feel free to unmute or type in the chat and I'll relay on if you can't unmute. But how's open source being viewed here in that framework?
So open source should be thought of like anything else that's going into an organization or your own capabilities. You should look at it as, a reusable thing, but that something that you want to understand how it was built, where did the pieces come from. So I think you'll see a lot of the tools and capabilities I talked about are very applicable to open source projects. They're meant to be straightforward. We're trying, remember, the focus of my work with SBOM was in the developer tools, the development environments, the infrastructure. That was so that developers, no matter where they get their tools, would end up having the ability to do SBOMs. Well, the same goes for these other, attestation creating activities. Those we're aiming to come naturally as a part of the build, creation, development pipelines, so that they should be available to anyone, whether they're in a big enterprise or working on a small one-person, two-person project.
Cool, thanks. Anyone else have any questions for Bob?
Hoping some of these things make sense for the safety, scenarios that were talked about earlier, that that
Well,
distributed ledger capability could be one way of, capturing the safety evidence you need to, reuse a project.
right. And I think there's actually a blog that just got posted last week, actually. That went through the various safety standards and basically pointed to how an SBOM can help address it. And so all of them seem to be counting for various information that is being picked up from these things, from these efforts anyhow. So using it as part of evidence seems to be certainly a direction we'd like to look at going forward with.
Yep. Well, I was trying to
Mm-hmm.
bring something that people may not have heard about or may not have thought about. Look forward to feedback and, seeing if these things need to shift a little to the left or the right, up or down, in or out, their community efforts.
Very much so. Looking forward to seeing more of that stuff become open so that we can get input. And then if no one else wants to ask any questions right now, we will say thank you very much. Much appreciated you doing it for us.
Yeah.
And
thank you. Take care.
Bye-bye.